I'm Quentin Bonnard from Craft, and we did this project with Frédéric and Frédéric. So first of all, I assume that most of us have been programmers. Am I wrong? Okay. So then most of you know the not so enjoyable sensation that you have when you realize that you will have to learn a big amount of code or to learn how to use a library. There are several ways to do that, like reading the documentation, which is not always up to date, browsing the code, reading the diagram if existing. More practical ways are to develop test cases or do tutorials or do debugging. So the fact that there are so many ways of doing that is usually a fact that proof and sign that there is no way that is better than the other, as there could be, for example, when you work on music or paper review or textbook learning. So there are idiosyncratic differences in how you do it, but usually it involves printing, reading, and annotating. Of course, with screens, it's not so easy. Actually, maybe the problem of getting grasp on the code is that you literally cannot get a grasp on the code because you cannot hold it in your hand and move it like that. So, oh surprise, we thought about a paper-augmented approach for that. Because we are not really ready to give up the advantages that an integrated development environment would give, like hypertext, for example, when you click on a function and you go to a definition, or you see the documentation, or when you search something, or when you want to browse classes, etc. But it still would be nice to have all these graspable advantages of paper, so I guess we are all aware of what they are, that you can lay out easily, that you can navigate easily, that you can annotate also, and that, yeah, since it's physical, you can even go further in cutting parts and rearranging as you want, photocopying, etc. But the problem with code that makes it not very intuitive to do a paper interface for that is that we cannot print the full code or the full documentation or everything. So that's the issue here. So to start off, we used the opportunity of a new member joining our team and the expert that had to explain him the big code base that we have in the lab. So we did this small experiment where we printed the classes in a UML-like, class diagram-like representation, and also we gave access to a regular IDE so that they could browse the code, etc. And with even this little experience study, we could have several observations. So the first one is that the paper representation of classes supports overview, as it can be quite clear by the picture. And it's true that almost 10 seconds after laying out all the classes under the novice eyes, he saw that there was a method that was everywhere in all the classes, and he did notice that that was a kind of architecture flow. Another note is that the classes, this representation, for example, is not enough. It's better to keep visual characteristics that were used in IDE, small cues like the scroll bar, how big it is. You intuitively use that to see how big the class is, how big the file is. There are other cues, of course. But the big observation, the big flow of this rather raw augmentation of paper is that the navigation should support several levels of granularity. So they started by just drawing a block diagram with the 4 components of the architecture, and then they went into some special classes in some of the blocks, and then into some codes, and then back to this class and how they interact. So this is not enough to support this. So just the classes are not a good interface to browse code. So this is the first concept that we could implement to address these issues, where we still have the classes as base components, but we can also merge them with other kind of paper objects. So you merge them and then it gives you a group. So this is how we would address the granularity navigation, so that you can group, or you could also start with the packages and on the other way have an action that will show the content of this group, and then you can print the classes. And on the other way, you can also have the content of this method, for example, with an other action that you point at a given method, for example. So this is a concept that we found actually in similarly in this paper prototyping tool for mobile interfaces, where you have this cycle of printing something that gives you a base for both the computer to augment and you to annotate. So both of these are added or changes in the content of the printed paper. And then again you can print it again to give it as a base, which gives a lot of possibilities, as mentioned before, like versioning, so you can keep a snapshot of how you were at a given point, which is good for design, but it's also good for exploration. For example, if you have 10 times the same class printed, then you will probably remember that this class was interesting, etc. And this concept is not only for object-oriented programmation familiarization, could be extended to a lot of other problems where we have to explore abstract data and that we cannot really print everything, such as a database model, which is often a problem when you join a database, well, any company that has an information system with a lot of tables, for example. Also statistics, if you have a lot of data, but it's not really easy to get a grasp on it for the same problem, etc. If there are questions, we'll take some now.
Thank you, Quentin. Any question now? Yeah.
So just to reflect my own programming experience when I program, so the classes I'm using become quickly outdated. So I change a lot in all different kinds of components. And so if I would use paper, then also the paper becomes outdated at the level of classes pretty quickly. So if I have 2 or 3 changes made, so on the tabletop, then I might have to reprint a lot and in a very high frequency.
So here the goal is really when you try to learn the code as it is now, so it's not really a huge issue, but even then, when you imagine that you have your representation of your code, you will make a big map of classes everywhere, you will link them and annotate it like that. And then let's say that one of your classes you will move everything, well, or half of your method to another classes.
Yeah.
You will still, you'll create these new classes, but the old class will probably stay at the same place in your big map. It still helps to have paper because you have this special memory that will remind you, and you will really visualize that you physically moved the content of this class from the other one. So you would still...
But, don't get me wrong, I like this.
Yeah.
So it was...
no, but that's trying to explain how that would also be a good scenario.
Yeah, I just thought it might... So if you have an evaluation and all this, so it might could be kind of a problem. So even for learning, because sometimes learning comes also with changing stuff and experimenting. So, but just a thought about. Yeah. So the overall approach it's nice to moving the code around, having it tangible.
Yeah, and even the fact that it changes, that you have to report this change on your map external representation, makes this learning of the change even more concrete.
Okay, thank you, Quentin. And the last talk before lunch.